Right. Welcome everyone. We'll begin session one, and in session one, we are going to go over some of the basics of Python programming. I believe some of you have seen those introductory videos that were the links were posted last week on Wednesday, actually. And basically, we have I've given information about added some information about how to cite this bootcamp and how to use it. So I welcome people to use this bootcamp in their classes, university, from primary school all the way to university. You can use the materials in your bootcamp. You can post it on your website. You can cite it in when you are discussing some lesson and so on. And all the video material will be accessible as well. So, okay, moving on. So we go into session one, and what before we go into session one, what did we do in our pre-session? Pre-session, we basically discussed how we can use these different operating systems, how we can use some of the online platforms such as Replit, and we went over some examples and then we have seen how VS Code works, how GitHub works, and how we can make use of all these technologies, which are basically free of use. So, I mean, there are a number of websites or web technologies which I could have used, but I have tried to use all the technologies that are freely available there. So this is mostly to promote people from developing world economies, from rural areas and all these other places to learn programming. And those people who love to learn programming, but registration, web and access has been always a problem. Now we have all these things freely available. So, and particularly, I have not been introduced to programming in high school, but I know that a number of countries are trying to do that, developing countries. And the challenge is always that teachers are having difficulty in grasping programming because they were not introduced to these concepts when they were doing the teacher training or in the university days. So there's a big challenge on learning programming and teaching programming, especially in developing countries. And some of those challenges also are in developed countries. It depends which state you are in, what location you are in, what resources are out there, and so on. But the good thing is that in the beginning, the price of a computer and a laptop, at least 20 years ago, was it was very high, right? And now computers and laptops are more and more affordable. These days, you can buy a laptop, a good functional laptop for $1,000 or less. And basically, these days, phones are more expensive than laptops. So there's some apps out there which you can use to do programming with your Android phones and things like that. But that is still there are a lot of limitations. So I would suggest that, I mean, if you can access Replit from your tablet or from your phone, you can use that Replit website for programming, and your phone can be used, but of course it's just too small and typing is always an issue. So I have placed some exercises here. We'll go over the exercises next. Let's begin session one. And session one of the first things to go into is conditions, if and else. And this is the very basis of programming, the very fundamental of programming. And let's see how we can we can learn and become proficient in this. So I quickly open my VS Code here. So right, so we can see that I hope the font is quite okay for you to see the size of the font. And so let's see if and else. And basically these conditions are used to check or make a decision about something. So every day in life we make decisions, right? For example, some of our decisions in our daily routine are based on time, right? And naturally we are so used to it, we don't really question our decision. For example, um, if I mean we wake up, and one condition that we usually follow, at least most of us I would believe, is that if you had brushed your teeth, then you would have your breakfast, right? So that is one condition that I follow. So basically, if so I check if I've brushed my teeth, then I have my breakfast. But that checking is naturally done, right? So that's just one example of if and else, right? So then there are many layers to things. There are many layers to this if and else rules, conditions, and some of these complex layers are used when making decisions. Some of it is used by the government, for example, when they are enforcing COVID lockdowns. They see how many cases are there, what's the population density, what restrictions are working, and based on those conditions they enforce rules. So conditions are part of our everyday life. So here we see an example where we have a number which is 3, and if we check, the goal of this is to check if it is a positive number, right? So when we run this, this is just a very basic condition, and it prints, if this is done, then it will print it is a positive number, right? So there we go. And 3 is a positive number, right? But you see that after that it says this is always printed. This is always printed. Why? Because this is not under a condition. So all those things that are under the condition, like if we move these, and in Python, note that in Python we are not, if you are using C++ or Java, you will use this curly braces, something like that, right? But in Python, we don't use these curly braces. So it means that if it is indented uh, and on in this order, that means these things are part of that if statement, right? So now this is always printed because I've moved it up. Let's see what happens. It says 3 is a positive number and this is always printed. But let me just make it a negative number, right? And that this is always printed. This part did not get executed. This part we don't see is a positive number. This is always printed. Let's see, but there's another, this is always printed, and I'm putting a plus there just to make things clear, right? And I place the asterisk there. So this is always printed. This part is printed, but the thing is this part did not get executed, right? So moving on, then we have let's just put it back to 3. So we're just checking if a number is positive. Anyways, I'm moving this back. So you can have 1, or you can have a number of these things in a follow. Oh, sorry, in a if statement. Your if statement does not always need to have a else. Just a if statement on its own is okay. Okay, but you can always put a else. So if that condition is not met, then you can always do something. And for example, okay, so we are putting a print statement. So if that number is not positive, then of course the number is going to be negative. Okay, so now let's see what it does. So in here the number is 3. 3 is a positive number, but let's say that if we made it -1, then we have this statement. The number is negative. So the first statement did not go through. Okay, but then there's another example about positive and negative numbers. There's another test with the same thing, but uh, let me just make this simpler. Just take the other one out because we have already tested both positive and negative. The other part is it becomes a bit more complicated when we are testing if a number is in between something, right? So let's say if the number is between 40 and 50. So here we need to kind of see this number is 45. Then if it is there, if it is in between those, then it will print this, right? But can you see it says number is greater than 40 and the number is less than 50, which means that it is not including the number 40 and not including the number 50. Okay, so if we say, let's say 47, right? So the first part is the printed one is there, but after that we see 47 is in between 41 to 49, right? But you see, if we put 50 there, what happens? That was not printed. So the first one, the negative part got printed. This is always positive printed. Then after that, we came to 50. And basically, this was not printed. Why? Because it is less than 50. Okay. So, and if this number was, of course, 10, then this will not be printed. Why? Because 10 is neither greater than 40 or less than 50. Okay. So we'll see more and more examples. And so just leave this back to something. So let's look at a range of numbers. So this is an example of how if, else if, and else. So if you have a series of conditions, so that means if you have a program where you want to check if that number is between 40 to 50 and 50 to 100, you know. So during the COVID vaccination process in New South Wales, or generally Australia, there was this medical advice. You know, if you are above 60, then you were given the first preference. Then if you were given, you know, if you are between 40 and 60, then there was another set. If you were below 40 or above 18 to 40, then you would have to wait that long for the Pfizer vaccination. So we have all these cases, right? So if we are writing a software to kind of simulate that process, then we'll have to use if, and else, something like this, okay? So let's say the number is 77 here. And if we run this, what do we get? So 77 is between 50 and 49. That's what it says. So this part of the loop, this part of the condition was not true. And then it checked this part of the condition and it was true. So it just printed it and it did not even go there, right? And actually this should be like this. Okay, make things neater. So if the number is, let's say, 10, what would it what would it say? So now basically came here. So 10 is either less than 40 or greater than. So can you see the statement O? So you could always also put O in this, in place of and you can also do O, but in case of O in a if statement, so if statements you can use and O, but that for O it would be some other condition, right? But it's not, O is not going to set boundaries. Here we are setting the boundaries, okay? But anyways, this is what is executed. So this is all about if and else statements, right? And next we see an example of where if and else statements are used. And this I briefly covered in the introductory session. So if and else statement, let's say that we are using it with the functions, and we covered functions in the introduction. What are functions? It's modules or the components of a program, and basically it helps you to make your program more efficient, more readable, and you can use chunks of your code in different places, right? So that's what functions are. And functions basically in here, basically the goal of this program is probably something that could be used by traffic officers, right? And they do have a machine, right? And they all they do is when they check your speed, and they enter that into the system, and the system basically tells what fine to give you, and then they tell you this is the fine, and that fine gets processed by the department, and it gets sent to you. Yeah, Australia has some of the most yeah, it's difficult to pay fines here. The strictest road code is here, and actually in Fiji, I mean, if you speed, if you have like more than 20 or 30 kilometers, then you can get $40 or $50, something like that. But in Australia, you can get more than $1,000 or $1,500 of fine. So anyway, so let's see. Let's run this. So check speed of a vehicle and you find. That's what's the goal of the program basically. So it's just asking enter the speed, and as we discussed last week, this input basically enables to users to enter things, and the int is there because what users enters are strings, meaning that the number that you enter, like 22, that is not read as an integer type, but that is read as a string, and you cannot do calculations on that on string. So you have to convert everything that you read, if you want to do calculations on them, as integers. Okay, so a string is more of, so it's read in as a text basically. So 22 is read in as a text, but we need 22 to be, for example, the number 22 to be an integer. So let's say that the fine is 90, then it says you have to pay the fine. So this part has been done here, right? So this part is just a speed function, which is simple. Basically, it gets that thing, the speed, and it just goes into here, and there's just a if and else function, right? It doesn't have any return value. So you can have functions that can have return values and functions that do not have return, right? So there's no return value, and it depends on how you want your program to be. And we have a slightly advanced function next, and that's what it's saying. You tell what the speed is. Let's say the speed is 120, and what happens, it says fine is 600 AUD. So there's a slightly advanced function. It takes the speed, right? This speed, advanced speed, I just call it a variable name. Is advanced speed, but it just generally means speed. And basically what happens is it goes into this function, comes here, takes that value, and then it has something called total fine, because the fine calculator, let's say, is not that that simple as on top, right? And we know that the Australian fine system is different. I don't know what exactly it is, the exact rules. I just made something up. This is not the Australian fine system, but as an exercise, you can adapt this code as an exercise fine system in your country, right? Adapt it and make it work and show it to your friend. Here, this is it's like a game. So anyway, so what is happening here? So let's say that 120 came in here, right? Speed is 120 and it checks this, then this does not get it. Then it checks this. Is your speed less than equal to or less than greater than equal to 80 or less than 100? Then there's something called base fine. We start with the base fine. And then basically checks the speed, whatever is the speed, it calculates the difference of that speed. So that's 120 minus 80. So the difference would be 40. 40 multiplied by 10 is 400, and 400 plus 200 is 600 Australian dollars. So that's the way it is fine. So you can put more, else if statements there in to replicate the fine system in your country, right? You can like imagine some other things, which is just for argument's sake. Let's say that the fine system is nicer to people who are above a certain age. Let's just assume, but it's never like that. Let's assume, or it's, let's say, stricter to people who, yeah. So let's say it's stricter to people who have a provisional license, right? Let's say that fine system is stricter. So how would you put that in your program? So what do? You can put provisional as a variable, right? And then you can ask the user if they are provisional or not. So the right. So, and I think this may be bool. Bool basically means boolean. It means either true or false. So the person will enter, a true or a false. So are you having a provisional license, right? So that's what you are asking to, the officer is asking you. And then this provisional license, basically you pass it, right? And in here, because now provisional. See, in here, this color is a bit light here, where this is dark, and if you click on it, all these things. So why is this light? Is because it's not used. This variable is not yet used, right? So you can always do things like put another perfect here, right? See, what I think I would do, I'm thinking of saving this in a different way. Okay, let's just leave it. And provisional. So if provisional is right. So if it's provisional is true, because you can either say provisional is equal to true, but if you just leave it as provisional, if it is true, this means the same. So it's you, but it's good to let's just specify it just for, you know. So let's say if the provisional is true, then your base fine instead starts with $500. And if the provisional is false, then you do the normal base, right? So and you can keep on adding this, but I'll just leave the rest as it is. You could put the provisional part there and below here as well. So I just wanted to show, I want to show that you could have, you know, more of these things there. So let's say it's 120. Oh, so that was the first one. Then again 120. We have a provisional. So you say true. Mm, somehow the boolean is not working well. So it's true. Fine is $600. So basically, if you say provisional is true, I mean, this is, I'm just saying that. So speed, okay, so let's see what, so now we are trying to see why is this provisional true thing is not working, right? So there's something wrong there. So we want to maybe print what we are getting from the user. Doesn't matter, right? So now so it's true. This is true is provisional. Okay, I see. Yes, so because our speed is that we are entering is too large. Actually, we should be, for this to happen, we should have between 80 to 100. The first one and the other one should, let's say 99. So note that, so it says provisional is true and fine is $690. Okay, for a speed of 99, right? Now let's do another one. 99, then again 99, but provisional we say false. So provisional is true, the fine return is $690. So the thing is, why is provisional is true? Okay, I'm running out of time. I will come back to this later. Okay, I will push this part in the GitHub after the class. But basically that's the general idea, and I may be making some mistakes somewhere. So 99, 99. So yeah, if the provisional is false, then it should say false in here, but it's not getting that information from here properly. And there may be a slight problem I made. I will push the corrected one after the class. But to show that I have a problem, Okay, let's move on to the next one. Um, the next one is loops. Okay, so we know that loops are important, and before I go into loops, I just want to open the floor for any comments or questions. Okay, so I think a lot of people have challenges when in understanding loops, right? What are the loops for? So let's say that you want to print numbers from 80 to 100, something like 80, 85, 90, 95, 200, things like that. You'll have to use a while loop or a for loop. Loops are basically repetitive structures. So let's say that we have, how do we use a while loop? While loop should be initialized with, uh, there's an iterator that it needs to be initialized, and then there's a condition, and then you do things in the while loop. It could be one line or several lines, and towards the end of the while loop, whatever is that iterator, that needs to be either incremented or decremented based on your while loop, right? So what does this while loop do? Actually, this while loop, let's just print it. Right. So the first one. So this is the first part, right? So the basic while loop, and it just prints from 1 to 5. Okay. And in this one, basically, inside the while loop, we are putting a condition which says if I is equal to 3, then we break. That means we leave the loop. So that means it's 1, 2, 3 only. Why? Because after the 3, basically, we break from the loop. Then find the sum of all numbers stored in a list. So in Python, you can have lists or arrays, and this is how you make lists. Basically, square brackets, and you put things in the list, and we're going to cover more and more lists. So if there's a list and you want to find what's the content of that list, such as sum or standard deviation or mean, then basically you need to go into the list. So similar to while loop, we have for loops. And in for loops, basically, you do not initialize the iterator as we have done here, right? That is done automatically. And this is basically a very refined for loop where we do not see how it is iterating. Okay, I'll come to more examples of this for loop in the next lesson. But here, what it is doing, it is taking each of these values out and basically adding to this variable called sum. So that's why sum plus val. Okay, and then at the end it says the sum is, that's the sum. Okay, so the sum is 48. Of all of these, the sum is 48. Okay, but let's just see how it is adding. To see how it is adding, you can always put up some print statement. So this one, so you can see that. So this is when we do print sum. So it's looping from the beginning to the end and taking each of these values and keeps on adding. So 6, then it added 5 to it, 14, and so on, and all the way to 48. Okay, so this is very useful when you have lists numbers, when you want to kind of get people to get programs to calculate things in lists, right? I can see some comments there in the chat. Okay, so Anshuman's loop, saying loops within functions. That's the syntax, but understanding the logic behind it. Johan's 1003 is talking about the extra bracket after provisional is true. Yeah, maybe there's a mistake somewhere there, but I'll fix that after this class. Right. So next we go into so yes, loops, and there's a comment about loops, so we go in these loops over and over again. So we have another one called fruits, right? This one is just like you want to print fruits. Okay, so basically the fruits are printed: apple, banana, and cherry. But generally in Python, if you don't do this, let's say we just say print fruits, what does it do? So it's taking each of these fruit and printing each of them, but let's say we just don't do that, we just print the whole list. So if you do that, it will print it like that. So the top one, the apple, banana, and cherry got printed one by one, but if you just print it as a list, automatically Python has this thing where you can print the whole list, okay? And the same thing, you could print the whole list of numbers, it will print. Then we have another one, powers of 2 for no obvious reason. So we have a for loop where from 0, so this is the, so the for loops that you saw before, these ones and these ones, basically they are most simplified for loops. I'm not comfortable with them, I don't use them. I usually use this one actually. So in this one, because you have more control, right? So basically it says from 0 to that, from that range from 0 to 21, we get all the powers of 2. So what it prints, it prints 2 to the power y is power, right? So we see 2, so 0 to 2, then 1, and it see 0 all the way the middle, all the way to 20, it's looping over that, and then it's just calculating the 2 to the power is equal to power. Okay, you can do many other computations there. So that's one thing, but what I was going at is that you can put a, let's say you can start from a different number. So you don't have to start from 0. Let's say you want to start with 4, but we don't want to go iteratively to every number. Then you would do something where, let's say you do 2, you put 2 there. What happens? Let's just see what happens. Okay, so now we have basic loops, and should start from 4. Okay, let's see, save properly. So let's say we started from 0, but then because we placed 2 there, so it's just going 0 to 4 all the way to 20, right? If you put 4 there, what happens. So you can see that it is going 0, 4, 8, 12, 16, 20. Okay, so where you start and how you iterate over can be controlled. Okay, so that is so far so good. Then we're going to go for scanning a list, and you have a list here, and then you want to, so length in any list, this is a list of strings, right? Strings or text, right? So you can have a list of names, and whereas this is a list of integers. Okay, for both of these lists you can get the length of the list with a simple length, len. Okay, so if I say something like this, so instead of starting from end, which is 0, we are starting from now. Okay, we're going all the way this way. So if we want to start from the beginning, then you will have to start from 0. Okay? And if you want to miss things in the list, let's see what it does. So now it just does 0, 2, 4. Okay, so it printed end, then it printed 4, then it printed completely, right? It couldn't print this one because that is not iterated. Why is just jumping every 2, but then the size of the list is reached. Okay, so this is what happens here. And moving on, there's another list here, and basically, as I said, that this is a easier way to go through this list. So Bill likes jelly beans. The print X, it basically goes through the beginning and from the beginning and traverses every value in the list. So it likes jelly beans, basically. So moving on, range. If you do something like what range does is basically, range is the inbuilt function essentially. So it goes from 5 all the way there, right? So let's say that we want to range works with to create traditional for loop, right? So I think we have covered the range part already. So you say you start from 2 and then you're going all the way to 10, but you can traverse it with 5 or 2. So it could be 2, 4, 6, 8, 10, things like that. Note that with the range, the last value is not included, right? So you are going only from 2 all the way to 9. Okay, you're not including 10. If you want 10 to be included, you'll have to say 11 here. Okay, you'll have to say 11 here. That means then the 10 will be printed, right? Then the same thing that I was telling you, 2, 4, 6, 8, and you see the 10 is not included. Why? Because the range basically covers from 2 to 9, right? And after 8, basically it exits the loop. And why is what is this print statement, this end doing, right? Why is this end there? So let's just take this end out, right? Let's just take this end out and we just leave that. What happened? So we just remember this, we have this. Okay, just remember that. And now basically, because print, if you don't put that end, basically it's automatically the print goes to the end of the line and it will start from the next line, from a new line basically. Okay, and the list you can iterate backwards too. You can iterate backwards where you start from a large number 10 and then it will go all the way to And note that the 10 is not included. Okay, so all these things are very useful. Uh, any comments? Let me check. Any comments? Okay, no comments so far. Right. So just quickly push this. What are these comments I keep on pushing? It's just for my own reference. Okay. So when you use GitHub, you want to just remind yourself what you did at that time. Right. So we are now going to cover something that's a bit more complicated. So we'll just cover nested loops. Okay. If you have difficulties with loops and you go over this and you go over the exercise for this week, then you should be okay in the future. Okay, so with the nested loops, I just want to introduce that in Python, we have lists, which I already discussed, and we have a broad range of libraries. And one such library is called NumPy. And you import a NumPy. It means NumPy is probably numeric Python, but I could always be wrong. But people just know it as NumPy, okay? And in the net, if you have problems, you put NP Python examples in Google. Google knows that NP is NumPy these days. So what we want to see is how are nested loops done. So nested loops basically are loops within loops. Where do you use it? So for example, when you're dealing not with a vector, but with a matrix probably, right? When you're dealing with a matrix, so let's say that you have a table of numbers and you want to add all the numbers in the table. So you cannot use a single for loop. You'll have to use a nested for loop or a double for loop, sometimes called, right? So here I just, this is just, another convention where you put define main, and then in the main, basically you call your functions. And this is the right convention to use. And if you modify this further in the future, you could always take arguments from the command line and use it with shell scripting and things like that. So it's good to use this convention. So, okay, so in this convention, we're just saying running nested loops. Okay, so I'll just run this nested loops. Right, so go up here, and I have this habit of just putting things in comment, especially websites and things that could be useful or not useful. Ignore if you don't like it, please. So we have length, width, and height, right? And let's say that we are creating, we need to create a matrix or a two-dimensional array. Let me just call a two-dimensional array a matrix, okay? So this basically created that matrix, and np.random, what it does, it basically uses the random number generator function in Python, and it is actually already part of NumPy. So we are accessing inside the NumPy the random, but when you don't want to use it through NumPy, so you can think your Python without any of these things. Think Python as your laptop, right? Think of it as your laptop. And when you put these things there, think of it as other laptops that it is connecting to, and there's code in other laptops, right? So when we put this there, basically it connected to this laptop, and these things are called libraries, right? So we're basically accessing other people's code, which are more professionally developed, so you don't have to do everything from scratch. Okay, so the thing where we in the previous one we were like, okay, let's write a function that adds some, that sums a list, that you don't have to write, because there are libraries such as numpy where you can generate a list, and there's an inbuilt sum function that will return you that list. So basically these libraries, basically they have a list of functions people have developed, and the efficient Python programmer basically learns how to use all these libraries. Okay, so you have different libraries. Numpy is a library, random is a library, system is, this is for accessing operating system things. These are all libraries. So we are going to get used to these and see more and more of these. So what happens here is that a two-dimensional, when we run that, we have a of size length and width. Okay, so length is 3 and width is 4. So this is the one that we see here. And basically with the numpy, you can do things where you can access certain elements of that matrix. So we have this created and we printed this called 2_dimensional, right? If we want to just get the first row, which is this one, you'll have to use this convention. So you have to use 2 dimension and then square brackets 0 and that. Okay, so that lists all the elements in the first row. And first column, this is not first column. Okay, this is the middle column. Okay, so note that in Python, these things, your whole matrix, this is indexed as 0, 1, 2, 3 and 0, 1, 2. So this is column 0, column 1, column 2, column 3, row 0, row 1, row 2, right? I know a lot of you are doing this programming bootcamp because you are excited about machine learning and data science, and eventually you want to learn and play with a lot of data, right? So this thing is going to be very useful because, let's say, imagine in the future you want to kind of read some data about something, right? And then you want to access only the first column or certain rows from the data. So this is how you do it. Okay, and then that's how the first and the second column got printed. Then we do there's another one which is a 3-dimensional array, right? Or a matrix of matrices, something like that. So in that one, basically we can generate that. Usually with numpy, if you want to kind of create a variable, you would have to say numpy 0. So when you do that numpy 0s, basically it will make in the memory structure that variable. So if you print numpy 0s, basically it has made a three-dimensional array. So you have of length, width, and height, right? So what is your length? Your length is 3, width and height 4, and height is 3. Okay, let me make this something else, so that's why, so that it's not confusing. Okay, so I go back there. So we have length is 3. That means essentially 1, 2, 3. Okay, so this is where it starts and this is where it ends. So you can see, because it's 3-dimensional, then you have 3 square brackets there. Okay, and it ends with this 3 square brackets. Inside the 3 square brackets, you have this, that, that. So that's the 3. The length is the first dimension. That's what that is. And the width basically is, in our case, the width is 4. So that means 4 rows. And the last one, the height, is the columns. So 4 rows and 5 columns. That's the data type that we have, right? And we just printed that. And now basically we want to do things there. We want to play with this. So let's say that we want to initialize this to some numbers, right? So not the 3 dimension. First we play with the 2 dimensions. So that's where the nested for loops come, right? So this is a for loop. This is an example of a nested for loop. So you have length and width, and you created your 2 dimension part here, which is printed here, right? This one. And let's say that we want to, rather than this random numbers, we want to rewrite those parts with some other numbers. And that's what we've done. We have essentially rewritten that. The top one that you had here, these random numbers that you had, we have rewritten that with this. How? So it was rewritten by I multiplied by j, right? How did that happen? So basically, that value of I and j, the way it starts is for I to the length, and then for every j in that length. What does this mean? Okay, so this essentially means that you will do something like this. I will be a 0, right? I will be a 0, and then you will do j of 0, right? Then you will do a j of 1, okay? Then you will do a j of 2, then you'll do a j of 3. But then the width, you have to keep in mind the width. What is the width? The width is 4. So you will not do 4 because the loop terminates, right? So what happens is, in the first part that you are putting is I and j, the indices here, I and j, both of them are zeros. Okay, 0, 0. That means you are referring to row 0, column 0. Okay, and in there row 0, column 0, you are just multiplying I multiplied by j, which is 0 times 0, and 0 is placed there. Okay, you are multiplying I multiplied by j, and you have 0 multiplied by 0, and 0 is placed there. Any questions so far? Right. Please put any part you want me to go over. Just say it again in the chat. Okay. So now next what happens? Next what happens? Basically, so you did look at this, right? So your I was 0 and j was 0. But next, what will happen? You will be I will be still be 0, but your j will become 1. So that means your I is your row. Row is 0 and your j becomes 1. So you are there, column 1. And in that place, what we did, what we are doing, I multiplied by j, that means 0 multiplied by 1, we put 0. Then next is I is still 0 and your j becomes 2. 0 multiplied by 2, we put 0. Then I is 0 and your j becomes 3. Then down. Next what happens? Next what happens is your I, basically, because now that executed, that finished, your I now becomes 1. Okay, so now your I becomes 1, and your j will be starting the same thing. Your j will be 0, then your j will be 1, then your j will be 2, then your j will be 3, right? So now we go here. So your I, which is now your row 2, so 1 multiplied by 0, first you are there, 0, 0, then 0 multiplied, then you have 1, 1, which is you are here, row 1, column 1. You see the coordinates, okay? Then you have, why is the value 1 there? Because you multiplied 1 by 1, and that's 1. Then 1 Then now you are still the same, you are still at the same row, but you change your column here. So it's 1 multiplied by 2, 2, 1 multiplied by 3, that's 3. Okay, so this is how this loop works. And then finally your row will become, this will become, well, I becomes 3. Okay, and then you'll do for 0, j of 0, j of 1, j of 2, j of 3, and you will do those multiplications, and then these values will be placed in that list. Okay, so this is how NumPy works. This is how you can traverse two-dimensional list. But mostly Python people don't do these kind of things that usually that commonly these days. But the exercises that are for this week, you will see these things are useful and you can use them in the exercises. And next week we'll use these more and more. So now we are doing the same thing, but we are doing this for a three-dimensional array, right? And that's the three-dimensional array. Okay, you can see. And the first one is basically, so you will do things like, you know, you will do things for three-dimensional. Okay, I'll just put it here. Okay, so for three-dimensional, it is your ijk. Okay, so this whole thing is your I, and then inside the rows are your j and the columns are your k. Okay, I is your let's say matrix, j is your row, and k, so what happens is, so you are in here, you are in your matrix 0. So this is matrix 0, this is matrix 1, in matrix 2. So in your matrix 0, you will go over each of those rows. Yes, so your row will be 0. Then for row 0, you are going to do, let's say, okay, I'll just write net, right? Is row first, and then 0 is column. Then you will do one column, two column, column 1, column 2, column 3, right? You'll do this. Then once that is done, that means all of these things are, what are you doing? IJK, all of these things are 0, so that's why they are 0, right? So now, and now, then you will do stuff like that. This will become 1, and you will do all the things again. Then you are going to do, I know it's getting a bit boring, 2, then all the things will contain. Then you will do 3, then all the things, all the columns will contain. Then you will do things like, now it will be your, this becomes 1. Okay, so let's say this is all done, let's say, and then we have, this will be 0, so it's these things, right? And then because then you will have, you are still at 1, your matrix is 1, then this becomes 1 is 0, which is this one, because your columns are 1 multiplied by 1, 1 multiplied by 0 is 0, 1 multiplied by 1 is 1, multiplied by, and so on, and all of these are multiplied, by 1, because you are multiplying ijk, I is still 1. Okay, so similarly you are going to continue this, and that's how you are writing all these things there. So the last one, you have these things. So basically this is very useful, I think. Let's say that we want to, yeah, So let's say we want to do another thing is we want to print, let's say or we want to take just the last two rows. How will we do it? So you will have to do something like three-dimensional, okay, right? And then you will have to play with these things, okay? So playing with this means, so you want to go into the last one. So that means definitely that's you're looking at 2, right? Matrix 2. And then you want to kind of look at the last 2 rows. So that would be row 3 to row 4. So that's inclusive, row 3 and row 4. And let's just say, okay, we don't want, we just want these two, okay? For these, so we don't take the, let's say, okay, first we take the whole thing. When you take the whole thing, you just put this, okay? That means it will take all of these guys. But from row 0, 1, 2, and 3, let's see if this works. I made a mistake somewhere. Maybe while I was typing, I did something because it's saying this is not declared anymore. Okay, I get it. So because I was giving writing all those examples here, maybe it missed my indentation. So the indentation is very important, and as you can see, that indentation is all messed. Okay, I hope it is not going to be a problem now. So you should indent it properly. Okay. So at the moment, I actually got the last one. Why? So it's because I'm saying 3 to 4. I should have said 2 to 4. Okay. Can you see? Right? Yay! This works. Just to clarify. So this till here, and then this one was. I can just put some more asterisks to kind of make things clear which one is what. Right? So the 3 asterisks. So we have these 2, and let's say that we don't want all of these, but we just want last these ones, something like that. Oh, sorry, we were here. We want these ones. Then basically you are going to play here, and you are going to say 3 to 5. Okay, so now we kind of copied that much. So it's in a way kind of using this as a for loop. Anyways, I'm getting late. I'll go over another one. We continue with the loops. So right, so nested loops, we are going to go into the other one, which is called nested loops underscore row. Okay, so it says enter any side of so this is the nested loops row. We want to see some more examples of nested loops. Okay, so it says enter any side of a square. 5, let's say 5. So what we see here is this patterns emerging. So we can use nested loops to print some interesting shapes. Okay, so with double for loop, you could print this. Okay, so with print, we are printing asterisk, and we are saying do not end the line. Basically, we ask the user for site. So with the two for loop, basically we print this. Okay, and because we are using I, and after this executes, the I will become the 4, I think. That's why we have to reinitialize the I. Okay, so whatever you can generally do with the for loops, the same thing you can do with while loops. And this is an example of a nested while loop, doing the same thing that your nested for loop is doing. So you see I is 0 and your j is 0. For I till the size, and then inside that there's a while loop. And note that this I is equal to I plus 1 is not part of the while loop. It is part of the while I loop, not while j loop. Okay, so the things that are there, what's printing is inside the j loop. So it's the same thing that I showed in the earlier lesson. The same way of traversing, the same way it will traverse here is just doing with a while loop. And in while loop, because we in a for loop, you can see that the iteration, the way it's incrementing the indexing, that is done automatically with the range function. You can imagine it that way. Whereas here, you have to specify the incrementation bit, right? So this is basically while and for loop. You can use either of them, but it is more recommended that when you're indexing, when you're going over matrices, lists and stuff, people use for loops generally. And when sometimes you have some algorithmic implementation where you sometimes have inputs from the users and stuff as well, then people use while loops. So here you have another interesting one where we have matrix, the size m and n. So you have same I and j. And here we are doing a print, but here inside the print, we have a if statement. See, if statements, this is a shortcut of writing if. It says if I in this or j in else, this ends, right? So this whole thing can be expanded as a if statement, but generally what it does is it places all this there, and then it prints the same line there, but it only prints the first one and the last one. And that is basically done with this if statement kind of gets, meaning that it will only put a asterisk, it will print only a asterisk, right? If this statement is true, else it will print a space. So basically all this, the middle thing, it printed a space, whereas the first and the last, it printed the asterisk because this statement is true. And the statement there is basically, it is just checking it is the first or the last, the first or the last. That's the statement. And how is the first and the last checked? It's checked by your n and m, basically, right? So without going too much into details, I would rush a bit. And similar patterns you could use to do this. Draw this. So this is again inside these loops you have that. So going further, speeding things a bit. So I have covered nested loops. I have covered this, and I will cover this another example here. Let's have a 1 minute break because this example is very important. So let's just close our eyes for a sec. For 30 seconds, let's close our eyes, or you grab your tea or something. Okay. So one of the most interesting things in Python or C and the programming languages are the special things that you can do with just two major operations. And one of them is division and modulus. What is modulus? It's basically the remainder, right? So, and the operation of modulus is just something like that, percentage sign. So let's say that we want to use these loops, and the thing is, in all these data science related and machine learning projects, usually people are not really forced to think algorithmically, and that's the purpose of the programming, because a lot of the data science machine learning projects are, if they are applied when you're not really contributing to algorithm development, you are mostly using libraries, you are cleaning data, and a lot of functions are already implemented, so it doesn't really challenge you to learn programming. So let's say that we want to design very simple coins stack, right? Change giver. So we go to the supermarket and we buy some bread, give $2, and the cost of the, you have $2 note, let's say, and the cost of the bread is 75 cents. The cashier is supposed to give you $1.25, right? So what the cashier does, the cashier looks at all these coins, and then there's no $1. Then what the cashier does is like, okay, let me give this guy 250 cents, 120 cents, 15 cents, and off you are happy with the bread. And then yes, so that is done in everyday life, and we really do not don't really appreciate the computational bit that is happening there if we are supposed to write a program. So now let's do this. So let's say we are supposed to give some change, and then basically the program is supposed to tell how many the coin denominations you have. So let's say we are giving 75 cents and we have 50, 20, 10, and 5 cent coin denominations, and let's say we have abundance of these. So 50 cents, sorry, 75 cents. How many 50 cents is in 75 cents? So that's where you use division. Okay. That's where you use division, and that's where you use remainder. So whatever is the amount, what happens here with 75 cents when you do a division, what is 75 divided by 50? Can you put in the chat, please? 75 divided by 50. All right, 1.5. So okay, let me put 1.5 there, right? Right. But you see, I have said int, means that this becomes a 1. Okay, because we cannot give a 1.550%, right? But if you say a 1.550 cents, basically that means it's 150 cents, and you take another 50 cents, you take a big chopper, you chop it, your chopper gets broken, you take it to a machine and cut the 50 cents. That's not possible, right? So we need a better way. So that's why we need to use int. So what the int does, so if this number was even 1, int is not same as rounding off, okay? So even if it was 1.7, the int will give 1. 1.99999, the int will give 1, okay? So that's what casting does. Then the remainder, what will be the remainder? Can you put in the chat? Any guess? What will be the amount? Okay. Text things in here. The amount is 25, right? So 25, right? Then we will come here. Now, what is the amount divided by 20? What is 25 divided by 20? Anyone? 25 divided by 20? So 1.25. Thanks, Michael. And what would be the int of this? Right, 1. So now we move into the next one. So what is going to be here? What will be the amount? So the amount is still your amount, the new amount. So your amount is 20 modulus 25. What will be your new amount? 5. Great. Thanks, Michael. So you can see that basically now the program says you give 150 cents, you give 120 cents. Then we are moving with the 20 cents. We are going here with the 5 cents. So what is here? What will be here? What is the amount divided by this? 0.5. Great. And here, so 0.5. And what is the int of 0.5? Int of 0.5, anyone? 0. Great. So int of 0.5 is 0. And now what is going to be our new amount? That's our old amount, which was 5 modulus, right? So the new amount is 5. Basically, you're still left with 5 cents. And then basically you take that 5 cents. What will be 5 divided by 5? Anyone? 5 divided by 5? 1. Great. 5 divided by 5 is 1. And then we have what is, so the amount is 5 modulus 5. What is 5 modulus 5? That's 0. Great. So you can see how this is done. And this is one way to implement that, right? So you have a series of statements. There's no ifs and else's there. So when you have a change calculator, I know naturally it was coming to your mind to use if and else. You're not supposed to use if and else. So now let's say that we want to use while loops to implement this thing again. Why? Because if you had, like, back in the days, we used to have what, $1 coin, 50 cents, 20 cents, 10, 5, 1, right? So you'll end up like always having a large program. Let's say we want to shorten this program. So what you do, you put it as a list, right? You put the coins as a list. Then you have some type of iterator, right? What do we see here? What we see here is repetition. And when you have repetition, what do you need? You need either a while loop or a for loop, right? Yes. So wherever there's code repeating, and a lot of us, you guys who are the new guys, you will end up writing code and you'll see a lot of repetitions in your code, right? And then you'll have to clean the code and you have to ask yourself, there are things that are repeating, there are things that I can save it as an array, and I can use these things with while loops, for loops, arrays, while. Most of machine learning algorithms are arrays with while loops, for loops, basically. Some complex arrays with while loops, for loops, most machine learning, most data science. Most of science and mathematics is basically arrays, while, and for loops, okay? And functions. So that's what most of the code is. So how do people do it? Is people have been observing things around them. They've been observing the patterns in nature. And when there are patterns, when there are repetitions, you can always make smaller versions of it. And this is an example of how you make a smaller version of it. So we know that you are going to keep on doing this operation. The cashier at the store will keep on doing this operation till the change that is given, that the person you're giving the change gets the money, right? So, and so in a way, where in here we see that the amount naturally comes to 0. So that is a terminating condition. So while we say the amount is not equal to 0, and what is repeating here in here? All of these guys here repeating, right? So basically I can put those things here. See, it's the same, basically int amount divided by 5, but that 5 is not here. Instead, the 5, I have coins, and in the coins I have in this, the index. Basically, And with that index, we are traversing the system. Okay. So that means we start from here. So the same example above, instead of 50, what the while loop will do? The while loop will get that 50 from the coins. Okay. And then it will get the calculate the new amount, give the print the change, then it will need to iterate, improve, increment your I, then it will go into the next one, the 20. So whatever the amount is left now, which is 25, I guess, right? And that will be iterated and checked with this, okay? And then it keeps on going there till it reaches 0, right? So this is the beauty of this. Any questions so far? Could you put, say, a yes or no? No, you really enjoyed this. If you really enjoyed it, just put something in the comments so I know that I'm not talking to myself. No questions, great. Uh, is this something new to you? Is this something new to you? Have you seen something like this before? Yes, for some of them, yes, yes, new. Okay, yeah, some people have seen this before. That's great. And sometimes it's not really covered in the some tutorials, but now it's covered. So now we go on the same thing that's while loop that can be implemented as a for loop. Okay, and in the for loop, because we want to see the coins, the length of the coins, basically what this gives, the length of this is 4. So it goes from, when you don't give the range 0, when you don't say from 0, it basically starts from 0. So it will, in this example, um, it's because it was the example I followed was US. I think they have quarters, dimes, nickels, pennies. Uh, so in that example, we have these candidates here, and basically something similar is done. But we are just, whatever is the result, we are appending it. Here we are not appending the result, but we can also append the result so that you have a list. At the end of the day, what your program should return is a list of results. Actually, the results is how many, one 50 cent, 20 cent, 10 cent, 5 cent coins you have. And essentially then you have another way of printing. This is so this part basically. So let me just run this code now. Okay, so the first part which we discussed, sorry, here, so you can see all that part is all given here, right? And then the same thing is done with a while loop, that's done there. And now we want to see new, it's just asking the user to enter how many, what you want. So let's say 76 cents, let's say. What does it say? So 25 cents 3 times, 10 cents 0 times, 5 cents 0 times, 1 cent 1 time. Okay. So then again we can say, but the thing is that this whole thing is manually written here, meaning that this could be written as a for loop, so, and that's the for loop version basically. 50 cents, 20 cents, 10 cents, 5 cents basically. So you have results, and it basically means how many of those you have given out. So this is all that is about forgive change, and there's another implementation of the same with a very basic for loop. As I said, it's not using the range one, so it's in coins. The coins is there, and this is the iterator, right? You could put I there as well, so it will go into each of those and get the value, because first it will be 50 cent the coin. So you see that this implementation doesn't have the square brackets, the index, whereas in this implementation, you see there's a I, right? And also in this implementation, I square brackets, but not in this implementation, but it does the same thing. So this is like a shortcut version of that. Okay, up and coin and so on. So this is all for give change. This is going to be used in your exercise 2. What we are going to do is simulate a vending machine. You know, the vending machine that you know, it's out there these days. It's more useful because I guess those vending machines could be useful for um, limiting COVID infections, right? So nobody is there serving you the drink. The machine is serving you. So you give like $2, you pick some things, then it gives you some change back. And also like parking meters, you know, you put some coins there, it gives you change back. So these are the kind of things that those things are using. So basically it will have coin stacks, and basically it switches on or off each of those stacks. Basically that's how it gives on the retains the coin, but there's some sort of software operating. But yeah, of course, before the software is this coin meters very mechanical, and mechanically you can also design them. Right. So I think covered most of the loops. Now we move into NumPy. So NumPy advanced, some more NumPy advanced stuff. So NumPy advanced. Let me open this. So again, the same thing. NumPy is NumPy. So we just going to main, and it's calling this advanced NumPy. What is it doing? So we have some certain operations. It's basically how you kind of do play with your NumPy, or this is very useful in data manipulation, right? So you have like two NumPy arrays. If you want to kind of, right, you have two NumPy arrays, and this will be useful, very useful in your data science jobs and projects. Okay, so you have two NumPy arrays and you want to combine them as one. So then you use something called vertical stack, mp.vstack. You're not implementing the vstack, but this function in that library does that for you, and it will retain a stack like this. So for example, you have actually the I and B is not there. Okay, so I okay, so we have I and B, right? We have I and B that has been created here, and you could create it using random numbers as well. You know, you have random numbers, two lists you are creating, and basically we want to combine them. So with vertical stack, it becomes like this. It becomes essentially a matrix. So 1, 2, 3, and 2, 3, 4. Both of them are combined into one. What a horizontal stack does, and the references for them are there. You can read about it. So horizontal like puts it next to the other one. So 1, 2, 3, and then 2, 3, 4 is there, right? And then you concatenate. That's what a horizontal stack does. And let's say we have a matrix which is a 2D, right? And then basically it's 1, 2, 3, 4, and then you have a list which is just a 1D array. So 2D array, you are trying to concatenate with a 1D array. So you have to ensure that part of the axis is same. And then basically this concatenate, basically if you say axis is 0, so it does 1, 2, 3, 4, then 5, 6 comes below it. And if you say axis is 1, then it, so in one of them it places it under it, and in one of them it places it on the side, right? So those are the two concatenate with axis 0 and 1. And if there's axis is none, basically it makes it into a single list. Okay, so these are some others. And then we have split. Let's say that you have a original x where you so the arrange function in numpy, what it does, if you put arrange and put some number, basically it will, from 0 it keeps on putting that number to the number. So it's like 0 1 2 3 4, and this is usually used in when you're plotting things as part of your x-axis, you know, sometimes you use this. So basically x split, what it does is it takes the x and then splits it into 3. So we have now 3 original, and the x split is now 3 arrays of size 3 each. Okay, so that's what it does. And then we have arrange and reshape. Reshape is very useful when you have single, you have an array and you want to convert it into a 2-day or a 3-day 3D. So you reshape and you tell the way you want to reshape it. So that is what it does there. And then when you have like a matrix, let's say, and you want to convert it into a 1D array, or you have like a 2D matrix, 3D matrix, something like that, you just say that dot flatten. The dot flatten will basically give that. And or so there's two ways of flatten. One is dot flatten, or you could just say reshape. Reshape, but you just put one part there, whereas this reshape is like you are putting it into a matrix, right? 3x2 matrix. If you put it into a list of size 6, let's say, but you should ensure that this size is same as the number of elements in your matrix. Okay, so that's all there. And then moving to load and save. So in a matplotlib, you can make plots. In Python, you can make plots, and this is a very basic example. For plot, you need to include matplotlib as pyplot as plot, this statement, and from there onwards. So if you have a list 1 2 3 4 and you want to plot it, then you just say plot plt.plot, put the list there, and you can put the levels, the y levels and the x levels, and it will basically plot that. So you could see that okay, so x, this is what was plotted, and it says some numbers, and you can also put a x level there too. Okay, so that's the plot part. And then let's do some other stuff, like we have random numbers, and we want to put some things in those random numbers. We have done this already, so I don't think that's a need to do this anymore. But one thing to note here, that when you are using Python lists, you use len. You use something like this. Let's say whatever is the list name, right? And this is used to give the number of elements in number of elements in Python list. So in some examples, we're replacing length. But this is like the shape is something that you use in Python. So this on its own, basically, this is used for NumPy arrays, basically. And this is very useful in data science. So 0 basically does that, and 0 basically number of rows, 1 would be number of columns, something like that, right? So that you could use to iterate over, and if you want to do stuff where in this example we are putting some numbers 10 by 10, and we're putting some things in there. And basically, and then what we are doing is we are trying to save it. So the example of this was trying to save this. So any list that you put random stuff, or and then I'm trying to multiply that b by 2. So all the elements of that matrix 2 is multiplied, b is multiplied by 2. We can print matrix as well. You can print and check, and then we try to save them. So in using numpy is a very quick way. It has save text. So with save text, basically we can save things, and basically you just put the numpy a list or matrix there, but you have to put delimiter means how the spacing is there of the things that's going to save, and you have to put the file name, what file name you want to use to save. So here I supplied it the file name in my magic, and then there are two other file names that it is saving as. So um, right, so and that format 1.2f or 1.5f, basically that is how many decimal places to each of the elements of the that is saved, you know. So you have like 5 decimal places here, and you probably have the 2 decimal places here, and the first one there. Okay, so these are all things there. That's loading save. So that's saving, and loading is basically whatever you save, you can always load that. So we are loading this file name. So in the main, we are saying numpy design. So we give it file name my magic, right? And then it created that design and it saved as my magic text, because that's the file name we give. And now we want to load that. So we did the plot example, and then after that we call the load file function. We give the same file name, and this is the load file function, and basically it's loading that file, and then it's plotting what it loaded on the screen, and it says it's loaded it. And then what we are trying to do is use matplotlib to make a heat map. So that's what it does, and it saves the figure as design magic.png. So that's the heat map that was made. And then we do a transpose of this. Transpose is basically you're shifting the whole matrix in another dimension. You know, you're shifting it along the axis. So I think my hand doesn't explain it well. So will the diagram? You can see that now, right? So that's the transpose. So this is the original, and this is the transpose. Okay, so that you can do very easily and that's needed quite a bit. And you can save that as a figure and whatever is the figure. And after you save, you should do a clear figure. So that's all on a numpy, and then we are going towards the end very soon. Now we are moving to recursion, right? So what is a recursion? A recursion is when a function calls itself, right? So what is factorial? So let's go here, and so we have covered most of these things, conditions, and now let's go to recursion. And basically you can see there's a recursion example there, and then there's a factorial code, and then factorial, I have it in a link to Wikipedia here. These are very brief exam introduction to factorial. So 5 factorial is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. In the general definition is n factorial is n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3, and so on. And you can see that there's a repetitive structure there. So if you have factorial of 100, it doesn't mean you keep on writing this or keep on writing that. You need to use programming, advanced programming style, such as while loops, or so, or other things such as recursion. So let's look at the case of recursion quickly. What is recursion? Recursion is a function that is calling itself. Quickly run this, and this is an example of recursion. Okay, so So this is the function factorial, right? As you can see, this is a function, and then the factorial of a number is that number multiplied by, so the number multiplied by the factorial of number minus 1, right? So can you see the example of recursion is when a function calls that. And when you have recursion, you should have a terminating condition, meaning a base case where the calling needs to stop. Okay, so that's why you have that factorial, and that's why the figure is here, where the calling function is stopping. So you have, for example, find factorial. What is doing? Gets the factorial of 5, then it calls the function itself, and it takes 5, then it multiplies it by 4 factorial. Okay, so in the code here, in the code here, takes the 5, right, and then it multiplies it, because 5 minus 1 is 4, then it multiplies it by 4 factorial, but it doesn't know what 4 factorial is. To know 4 factorial, then it comes back here, and then it has to call itself, and it checks the base case. Is x 1? No, x is 4 now. So it will do this again, then it will be like 4 multiplied by factorial of 3. Okay, because 4 minus 1 is 3, then it goes back, is 3. Now it this doesn't, then it does 3 multiplied by factorial of 2, and goes back there. 2 is x is equal to 1, 2 is equal to 1. Now 2 multiplied by factorial of 2 minus 1, which is 1. The x is 1. Yes, so now we return. Okay, so that's what being done there. So it's 5, then 4. Now then you go back. Then you do this 4 factorial, 4, 3 factorial, 3, so 2, because 2 we do not know what 2 factorial, so you have to do 2, call that function again. Now 2, because the return case is there, so okay, 2 by 1, then you got this, then you'll take that 2 by 1, which is 2, and then you'll place that answer there. So that's 3 times 2 is 6. Then you go back, then you place that answer there. 4 times 6 is 24. Go back, 5 times 24 is 120, and that is the factorial of 5. Okay, so that's how factorial is done with the recursion. And factorial, actually recursion is not the most efficient thing in factorial, but recursion you'll use in other things. And one of the assignments is to use recursion. You can use recursion for a project where you can navigate a maze, like a game. A robot navigates a maze. It goes and looks for things in a maze, and when there's a wall, it exits the wall, and so like so on. But anyway, so the whole thing, we'll go over that next. The whole thing can be done in an iteration style, which is the idea of dynamic programming is you're building from past solutions, right? So the factorial iteration is an example of a dynamic programming approach. So where you can use a for loop basically, and basically it's like I to whatever factorial, because this is your base case and you are iterating, multiply by I, and then you can get the new factorial. That value factorial keeps on updating itself, right? And let's see it's starting from I and all the way to, starting from 1 and going all the way to I plus 1. Okay, the thing is that so I've tried both, and in programming you can always, it's good to know the time. So I've imported the time, and sometimes you can check how fast is a function by checking the start time and the end time. Okay, so here we have factorial. We're using recursion, and then we calculate the time and the value, and we are trying to find the factorial of the number 100. It's a big number. And then we do factorial with iteration, and then we calculate the time. So the iteration one took 0.0301 and the and 0.005. So that's the recursion one. So the recursion one takes more time than iteration. Well, in the case of factorials, it's wise not to use recursion, but recursion is a very good way to explain, factorial is a very good way to explain recursion, okay? And there are a lot of recursion examples out there, and one of them we'll see it in our exam exercise, actually. Okay, so moving on, so we see we've done all these things. Session one coming mostly to an end, and then the thing is, what do you do? You basically spend as much time as possible. There are 5 parts of the exercise. I know it's a bit too much of a demand to ask you to do over this in the weekend. We are not going to expect everybody to do the 5, right? If you are an efficient programmer, if you are good in programming, you can leave part 1 and part 2 and address the others. But if you are introductory, then you can just start with the body mass index. So this is an example of how you can use if and else if and stuff like that to calculate these, and then get some things from the user and keep on repeating this as a while loop. Okay, so there's a number of things there. You can read this up, and feel free to post questions in the forum. And so that's the first part. And I said earlier that there are good ways and bad ways to do things. Of course, you can make a building that lasts 100 years, and you can make a building that falls in 5 years, right? And so the same is with coding, right? So sometimes you can write really bad code. So I just wanted to give an example of bad code, and it's done by somebody I know who did a short time work with me. I don't want to name and shame everybody because I used to be that person as well, but that's why I just copied their code. And basically it's trying to create some kind of a matrix, but what it is doing is having too much of repetitive code and trying to save it. So what I want you to do is to think of how to improve this, right? So that's just one part of part 2, and the other parts are interesting ones. Of course, all of this is supposed to be interesting, and I'm trying my best to make it so. So you try to use the portfolio stuff and try to do this. Don't underestimate this. This will really, that's why I didn't really go in too much detail, because you will only know it when you do some exercise. Okay, so try to do that, and then try this as well. It's something to think about. And then that's the fourth part, is you try to improve that code, and you can be more creative, generate some data and run some matrix operations just as I did, and try to plot heat maps and histograms. How do you make a histogram? Heat map I've already shown, but I did not show how to make a histogram. Probably you could Google a bit about it or follow the links. So it's more about learning and relearning here. And then part 3 is more about loops, and it's about implementing something about prime numbers, so basically you blindly follow this algorithm here. You can read a bit about prime numbers in the Wikipedia, and there's a theorem of arithmetic problem there to make all these functions, and try to do this so that when you give a number, then it gives you these factors, composite number entered by the user, prime factorization. So that's the part 3, and part 4 is right, it's numerical integration. Okay, so I think most of you know about integration and numerical integration. If you want to know more, you can read the Wikipedia link, and there's some sort of solution already there. So please do not click on this link. Try to think about this problem yourself. Basically, if you have any function let's say the function is x squared plus y squared. Okay, right. Let's say the function is just x cubed plus 5, something like that. How do you, and you need to integrate it from -5 to 5, then you follow something like this. So how do you do this? That's something for you to brainstorm. Okay, and we'll go over we'll discuss some solutions next week, not all, and because this bootcamp is open, let's say the content is open there, and this is and then we can do this because it's open. You can take the next few weeks to address some of these things. And this is a very simple program about maze navigation. So let's say, you know, you have a robot and this robot is just moving around looking for something. You start somewhere and then you want to find this source, and this is where we use recursion, right? And that's like you have this, you just blindly implement this algorithm called find path, which basically calls itself, and it has some base cases there, and basically it is iterating over a matrix that you need to specify. So this whole maze, you can build it as a matrix where in the matrix you can put zeros and ones. Basically the ones would mean that they are walls, so you can manually make this in a file and do it right. So we'll go over this bit more hints about this next week. So if you are able to do it, please send me an email, send me your solution, so that I can also show it to the class. Or if you don't want it to be shown to the class, you just want me to see it, and just specify it in the email. I would like, or you could post your solution, basically post your solution of any of these in the programming bootcamp list. I would suggest those of you who have not attempted it, do not see solutions or discussions of, let's say, okay, you are, let's say, struggling with the exercise 1, part 1 and 2, and somebody posts a solution of 5 and discusses it. Don't see that, just ignore that. Just focus on what you know. Rome was not built in a day. And if you feel like part 1, Rohit thinks that I can just do it very easily, but I can't do it, what does he think of me, things like that, that's very natural. In the beginning you always get upset with the teacher. We all did. The thing is like programming takes years to master. You're new to it. Just a 2 to 3 weeks boot camp will not make you an efficient programmer. This is boot camp for me to show you the road, and you have weeks or months ahead. Some of you are busy in your work, in studies. You don't do this right now. You can always come back to it. The boot camp videos will all be there on YouTube. This GitHub will be there, and the Google groups will be there. Okay, so this is all. So now I open the floor for questions or comments. Okay. Okay. There's not much question or comments at the moment, so I'll just stop recording maybe